What's up everybody, this is Suleiman from SAZ. This is the channel where we talk about the money in business and the business of money. You've probably clicked on this video because you want to learn how we managed to increase the revenues of our client by 168%. Before I even go there, the first thing that I will need to explain to you is that any business should have a record-keeping system. Now, majority of the times when we say record-keeping systems, people think of the financial record-keeping system, meaning that they have their general ledger accounts. So they might use something like QuickBooks or any other accounting software just to record the transactions that have happened. Well, that's good, but that only records the financial records of the business. What you need to be doing is to record all records. And when I say all records, it's basically everything that the business is doing. And especially because maybe you are a small or medium-sized enterprise, you need to record everything. As you have heard, data is the new gold. And if you don't have the data, you can't make informed decisions. And what we actually found useful when diagnosing this client of ours is that they had records for almost everything. I'll give you an example of things that you need to be recording. So for example, you're a product-based business and you're selling products, right? Goods, right? Now, when you're selling these goods, you need to be keeping like information. Were you doing an ad, or were you running a promotion, or was there a campaign, or maybe you did a media tour? So you need to keep all these records in order for you later on to come and analyze them, right? And if you're not already keeping these records, then it's high time that you start, because at the end of the day, we need the data so that we can make more informed decisions. And for us as consultants, we really encourage you to do so, because we can never optimize a business that has no data. We need to know what has been working right for you, what has gone wrong, so that we see areas of improvement. Now, let's go back to the case that we are presenting today. We managed to increase the revenue of our client by 168%. Now, as you may already know, business is about money. Money is about numbers, and numbers can be manipulated and played with using mathematics. Now, the math that we used in order for us to understand how we can optimize this business is actually in statistics. So we used a multilinear regression analysis in order for us to establish the relationships between two things, if I can say. So the first thing that we wanted to understand is the revenue. And of course, revenue being, I can say, a dependent variable. Yeah. So it depends on other things that occur so that we know the revenue. And then there's the independent variable. In this case that we'll be presenting to you, we had two independent variables. So we had online advertising and we had traditional advertising. So what we wanted to do is understand the relationship that traditional advertising had on revenue, as well as the relationship between online advertising and revenue. All this will make sense once we jump into Excel, and I'm gonna take you step by step so that you can understand how you can use regression analysis to understand the impact of something on another thing, meaning the impact of the independent variables on the dependent variables. This will help you make better decisions. And as I'm opening my laptop, please take the time to subscribe if you haven't already, and also like the video, because that helps the channel out by sharing this video with like-minded individuals. If you wanna really please me, then share this video with at least one person, and I appreciate that.
Alright, so here we are at the computer. So basically what we'll try and show you today is how to use a multiple regression analysis in order for you to assess the impact of the decisions that you've made. So we'll start off with the linear regression output. And a simple linear regression is whereby we are evaluating one dependent variable. In this case, this is the revenue, and one independent variable. Yeah. So for example, the number of Instagram ads run by this company within the course of the year. So the Instagram ads are independent. So we can have 1, 20, 100, 195, 50, 135, right? But the revenues are now dependent upon the number of ads that the company ran. Okay, so once we have understood that, and here we have some totals just to show how much revenue was obtained and how many ads we did, and also we calculated the average number of ads that were there. As you can see, it's 116, and the average revenue per month, which was just below 17,000, right? Now, I wanted you to know and understand, first of all, the simple linear regression, because if I jump to the multiple regression, then I might lose some of you, of which that is never our intention. So if you already know how to conduct a multiple regression, then I'll put a timestamp in the description below so that you can jump to there. But if you don't know, this is a great place to start, because this offers now the fundamentals in order for us now to understand how to conduct the multiple regression. Okay, so I'll try and explain to you something that we learned in school, right? So let me try and get the equation. Let me just try and ink it so that you understand. Okay, so I don't know how many of you remember this, but we used to learn this in maths, and this formula was y is equals to mx plus c, right? So let me just insert it here because we'll refer to this. So y is equals to mx plus c. This is the equation of a line. Okay, so y is for the dependent variable, is equals to m stands for the slope of the line, x is the value of the independent variable, and c was the intercept. If you had a Cartesian plane where the line crosses the y-axis, that would have been the intercept. This formula was used to describe a line. So if we use this, for example, now we can take Instagram ads and revenue, and then we just take both of them and we go and insert I want a scatter plot. Yeah, so we can go to recommended charts, and once we have this chart, which is the scatter plot, we'll select that one, and basically we have here a chart that shows the number of Instagram ads on one side and the revenue on the other side. And as you can see, we have the points here which represent every line. For example, 180, 22, 755. So 180 is about here, and we got 22, 755, which is about in the middle somewhere there. So it's this point here. So we have marked this point in a scatter diagram. Yeah. So we can click on one of these points, right click them, and then we say add a trend line. Okay, so what Excel will do is add a trend line or a line of best fit. In the properties here, we can decide to add the R² value as well as the equation of the line. So I'll do that, and then we'll just close this here. Now I can move this somewhere where they can be seen easily, and I can as well get rid of these lines because they're just being cumbersome. Anyway, so now we see here that y is equals to 78.075x plus 7,930.4. Okay, and then the r squared is 0.9327. So based on this information, if we go back here, we can understand now, whereby for now we have dedicated that y is the revenue being the dependent variable. So it depends on how many Instagram ads we run in order for us, now based on the number of Instagram ads we ran, we can calculate now the revenue. And this is an approximation because, as you see, these points are not really on this line. So we're trying to create this data to fit in this line, and this is the line of best fit. So it will give us a kind of approximation of how much revenue we should expect. So based on this formula, y is equals to, so this line, it is equals to the slope of this line, which is 78.075, and then we'll put the value of x, which is the Instagram ads, then we'll add 7,930.4, and this 7,930.4, in this case, it's the y-intercept, where this y, if we were supposed to extend it, then it would reach there at 7,930.4. So based on this, now we can come here, and on this square here, we can put the slope. So the slope, it's 78.075. So we'll just put 78.075. Okay, and on this one we'll put now the intercept, which is 7,930.4. so 7,930.4. okay, so based on this formula here, we can now calculate, based on the equation of a line, how much we would actually get in revenues if we had 100 Instagram ads. Okay, and we'll just use the formula, right? So y is equals to m, which is the slope, so I'll just put it there. Don't forget to lock it with that F4, and then x, so we'll multiply that by x, and then it's usually just best practice to put this in parentheses because we want that to start before we add now c, which is the intercept. Okay, but Excel of course is intelligent enough to know the order of functions, but anyway, it's usually just to be sure and on the safe side to put them in parentheses. So once I click enter, we'll find that if we run 100 ads, we are kind of estimating that we'll get 15,737.9 in revenues. So let me just go back and lock this cell because I forgot to do that, and I'm locking that cell because I want to paste that formula down. And basically now if we run 150 ads, we are sure that we'll get 19,641.65, and if we run 200 ads, we are forecasting that we'll get around 23,545.4. Another way you can do this, if you don't want to go towards plotting the data, is you can use the forecast function. And this function comes in really handy, especially when you have a lot of data and you don't want to waste a lot of time. So you'll come to the cell that you want to forecast, and you'll just write forecasts, open the parentheses, and then it will ask you x. So what is x? So x is this one, and then we'll put a comma, and then the non-y's. So the non-y's are the dependent variable, and don't forget to lock these cells because we will want to drag this down. So we'll add now the known x's, which are the independent variables. So we'll just add all of them or select all of them, and then we'll just close the parentheses, and also making sure that the dependent variables are locked where they are so that we can drag the forecasts down. And once I press enter, you can see here that for 100 we'll get 15,737.88. okay, and it's more or less the same as this one, as you can see. And if we drag this one down by selecting and pressing Ctrl D, you can see that we are at the same forecasting solution, meaning that we are kind of confident in forecasting that if we do 100 ads, we'll get 15,737, 150 ads, 19,641, and 200 ads, 23,545. okay, so that is how you can use a simple linear regression in order to understand the impact that something has on another thing that depends on it. So even here we can just change, and it's not maybe the Instagram ads, it can be how many times you appeared on TV shows and the amount of revenues or the sales that you had, or it can be every time you post, just a simple post, let's say a reel, to the number of followers that you obtain. So you can kind of estimate, and once you have this data now, you can play around with this, because you can say, for example, our budget is only for about, let's say, 400 ads, and once you do that, automatically it should tell you how much revenue you are expecting to get. So that's the beauty of having this in formulas. Now let's go to the multiple regression analysis. So here we have pulled in data. So for the year 2021, our client, this is how they spent their ad budget. So the good thing is that we worked with our client and we established a system whereby we could capture this information well in advance, and then we could now analyze this and tell our client what works and what doesn't work. With regards to this, we can just do some simple totals. So the ads that our client did is that he grouped them into online ads as well as traditional ads. We were recommending that they should move away from traditional ads and go towards online ads. Now that we have the data, we wanted to prove that the decision we made was actually right. Now we can also get the averages. Now that we have this one, we'll employ the use of Excel's analysis toolpack so that we can understand what's going on. So I'll just come to an empty cell here, and we'll go to the data tab, and then select the data analysis toolpack. So what we want here is we want to conduct a regression analysis. You'll click on OK, and it will give you a window whereby you'll input the values of y being the dependent variable. So we'll select all that, and then the input range of x. So we'll select both of them at the same time. Yeah. And then we'll let Excel know that the first row includes labels, and we'll want to test this at a 95% confidence level. So the answers that this solver will provide, we want to be sure if we run 100 times, only 5% of the times, or only 5 times, the answers might not be correct, but 95% of the times the answer should be correct. Now here it will ask us for the output range. So I had prepared a sheet where it will host the outputs of this regression. So I'll just select on cell A4, and then we can just click OK and get the data. This is the summary output of the regression analysis. We'll start here, the multiple R, then we have R-square, we have the adjusted R-square, the standard error, and the number of observations. And being that it was in just 1 year, so we expect like 12 observations, in the sense that all these account for one observation which happened in January, and all these are one observation which occurred in February. So of course we only have January till December, so that's 12 months, and those are the 12 observations. One thing I forgot to let you know is the R-squared. So what is the R-squared? The R-squared value, we also call it the coefficient of determination, it's like a value that explains what percentage of the revenue fluctuations can be explained by Instagram ads. Okay, so the R-squared in this case here was about 93.27%, meaning that the fluctuations in revenue can be explained by the number of Instagram ads by 93.27%. So there is like a 6.73% that is unaccounted for, and these can be other external factors that are not in this model. Okay, so it might be the season, it might be the economy, something that we have not really captured. But if we had captured it, then we expect the number to be closer. So in the outputs that we have here, if we look at the R-squared value, it's about 76.7%. So these two factors, online ads and the traditional ads, account for 76.67% of the fluctuations of the revenues. And then we have the adjusted R-squared, which is more conservative but more accurate. So the adjusted R-squared tells us that these two variables, being the online ads and the traditional ads, account for 71.48 or 49% of the variability of the revenues. So we can explain the changes in revenue by 71.5%, and it's coming in from the ads. Okay, this is the ANOVA. ANOVA stands for the analysis of variance. I won't explain this much, but what we look at most of the time is the F, which this one is the F calculate value, and there's also an F critical value, but I won't explain that, and the value of significance. And this value of significance shows for the entire model, meaning the two independent variables and the one dependent variable. And most of the times, because we are testing at a 95% confidence level, we expect this number to be lower than 0.05, which based on these outputs, we can see that it is significant, because at times you might think that you have a relationship, but is it really statistically significant, or is it just due to sampling errors? Because at times you'll see that the sample is trying to give you some false hope or some false information, and that's why we have to test for the significance. Right here we have the intercept, and this is the value of the intercept. We have the coefficient for the online ads, which is 7.547, and we have the coefficient for 0.1924. Now, for us to understand all this, I'll go again and insert a formula here. Where is this formula? Okay, I'll try and insert a formula here just to explain to you how we can understand this.
So of course we are testing for y, and we'll say y is equals to b. So it's b 0 plus b again, b1 x1 plus b2 x2, and you can literally just go on with the same until you reach a point where it's b n xn, meaning that where n stands for the number of observations, right?
I'll put it here. So now I can explain clearly. Y is what we're looking for, which is the revenues, and B0 will be the coefficient for the intercept, plus B1, meaning B1 is the coefficient for the independent variable 1, times X1. So how much did we put in for the online ads? And then B2 being the coefficient for traditional ads, and X2 being how much did we put in for the traditional ads, right? And based on this formula, we can understand now how much revenues we are expecting. So what I'll do is I'll copy this one and paste it just here so that we can check. So I'll add in a little bit of space so that we have everything just on one view instead of scrolling up and down, up and down, up and down. And then we'll now conduct the analysis, right? So here, the first thing that we have is online ads, followed by traditional ads, and last but not least, we'll have revenue. Yeah, and we can make it bold. So in this situation, let's assume that we'll just put in 100 worth of online ads and 100 worth of traditional ads. I'll go back here, take this formula so that you understand what we're doing, and come back here and also paste it there. So we can have the formula somewhere there. Okay. So because these are not formulas, we'll just change the font colors to a blue, because these are hard-coded data, and here we'll put in the formula. So the formula is equal to this, and then we'll lock it so that it doesn't move, plus B1, which is this one, times what we put in this. Okay, and then of course it's good practice to just lock this and also lock this. And because we are using this coefficient, we don't want it to move, so we'll just lock that cell. And then we'll add for the second variable, whereby it's B2, which is this, times the amount that we've put in, and we'll just lock cell B6 by pressing F4. Now, if we add all this, we'll actually get a loss of about 573.8, and I'll just copy this forward so that we have that for reference. Now, what we want to check here is, for example, if we just put in online ads and we had no traditional ads at the same value, we are still getting a negative. And if we had 0 online ads and $100 into traditional ads, we are getting a bigger loss. So this one seems to have a drastic negative effect, but we are not yet certain. So what I'll do is I'll take this second scenario here and put in these values so that we understand if the model works, because this is data that we already have. Yeah, so I'll put in 15,840 on this one and 29,840 on this one. And here, as you can see, we were supposed to get revenues equivalent to 123,951, but it's more than what we got. Okay, and the reason this happens is, if you come back here, you remember here when we were saying that this is just a line of best fit. It does not forecast accurately, but it gives us an indication of what really happens, because as you can see, this is higher than the line of best fit, and some of the observations occur actually below the line of best fit, such as this one and this one. So in our case here, the calculation is all right to a 95% confidence level. So we are quite confident and sure that we could have reached at 123. But again, if we go back to the regression output, we see that the variability of the revenue is only explained at 76.67%. So we still have around 23.3, I think. Yeah, 23.3% that we cannot explain. And that might be the reason why we have different answers here. So what we wanted to understand is, since we think, and so far based on what we did, we have understood that online ads have a stronger positive correlation with regards to the revenue, we wanted to see if we decided to put all the advertisement budget to just online ads and leave traditional ads with a 0, what will be that impact? So the total of this and this, we can just use the formula, which is sum of these two, and that's what we have. And for this one, we'll just put in a 0. And as you can see here, we have now $343,434, meaning that if we decided to just do online ads and we skip the traditional ads, this is the amount of revenues that our client could potentially get, and we are sure at a 95% confidence level that this will be the case. Now, if we take this 383, so I'll just insert another line and maybe another one just to keep things clean. So if we take this one, this so is equals to this, and we subtract it from what we actually obtained as revenues, and I'll put this in brackets because I want to divide the answer by the amount we got for revenues for the previous year, so that we can see the percentage change. And sorry, it's showing in dollars, but let's just switch it up. So we actually can increase the revenues by 215%. Now you might be wondering, so why was I saying that we increased the revenue by 168%? Well, that's the information that we obtained from our client as of the 15th November 2022 regarding the increase in revenues that they've had so far in relation to the 109,125 they got from the previous year. So we are still in November, and hopefully by the time data comes in for December as well, I might do a follow-up video just to let you know if they actually increased their revenue by 215%, meaning that they got revenues worth $343,434.8 for the year that will end 31st December 2022.
So there you have it. That's how you can use a regression analysis for you to make better decisions regarding your business. If you want to learn more about such techniques and methods, then be sure to hit the subscribe button down there if you haven't already. And also, if you found this useful, don't forget to give us a like. That is how we measure the performance of the contents that we are putting out. And also it helps with the algorithm in pushing out this video to others. If you are a small and medium-sized enterprise that's looking for a consultant that will help you optimize your business, then you are at the right place. You can contact us through our social media platforms at SAZBizConsult, and you can give us a call and we'll surely be there to help you. And until the next time, build your future today.